In question 4, we have monochromatic light shone onto a metal surface, emitting electrons due to the photoelectric effect. In A part 1, we need to state and explain the effect of increasing the frequency of the light on these emitted electrons. Well, increasing the frequency increases the maximum kinetic energy of the ejected electrons. This is because as we increase the frequency, this increases the energy of the incoming photons. In part 2, we need to state and explain the effect of increasing the intensity of the light on the emitted electrons. Well, increasing the intensity of the light will increase the number of electrons emitted per second. This is because as we increase the intensity, this increases the number of photons emitted per second. In B, we're told the original wave model of the nature of light was rejected when there was validated evidence supporting a particle model of the nature of light. We need to explain what is meant by validated evidence. Well, for evidence to be validated, an experiment would need to be carried out to test a particular theory, and the experiment would need to be reproducible. In C part 1, we're told the threshold frequency of lithium is 5.5 times 10 to the 14 Hz, and we need to calculate the work function in an appropriate unit. Well, for that we need this equation, that HF, the photon energy, given by the Planck constant multiplied by the frequency, is equal to the work function phi plus the maximum kinetic energy of the ejected electrons. But at the threshold frequency, the electrons come off with zero kinetic energy, and therefore we get that the photon energy is equal to the work function. The Planck constant is 6.63 times 10 to the minus 34 joule seconds. This is the frequency given in the question, giving a work function of 3.65 times 10 to the minus 19 joules. And in part 2, we need to calculate the maximum kinetic energy of electrons when light of 6.2 times 10 to the 14 Hz is shone on the surface of lithium. Well, for this we use the same equation, but now it's the maximum kinetic energy we want. Putting in the values given gives an energy of 4.6 times 10 to the minus 20 joules.